Check, check, audio. Check, check. Check, check, audio. Check, check.
Okay, why don't I adjust the audio a little bit then?
Can everyone hear okay? Are we good? Okay.
Cool, can everyone hear me now? Awesome. Welcome everyone. We're finally here, ZR26 Unveiling. Thank you very much for coming, firstly. It's awesome to have so many people here. I've never had this many people staring at me, so that's kind of cool. I just want to say, firstly, thank you for coming. This team has worked very, very hard to get to this moment, so the fact that we have so many supporters here is really, really cool. For those that don't know me, my name's Andrew Ranieri. I am the current team captain of Zips Racing here at the university. Obviously, we're here to show off our newest car, there's a current bet that I am going to go over 15 minutes. I need to win some money, so I'm going to try and stay under, but we'll see how that goes. Thank you again for being here, and yeah. So I guess I just want to start off by, again, saying thank you to all the parents that are here that let me basically hide their kids in a basement to build a race car for the last 10 months. It's taken a lot of work, a lot of late nights, but we're finally here. With all that out of the way, why don't we get to the reason we're here? We're here to unveil ZR26, otherwise known as Layla. We name the cars every single year, and so that's the one we chose this year. Like I said, I'll try to consider time as much as possible, but I do want to paint a full picture of what we've worked so hard to do this year. I'll kind of get into what we do as a team. For those that don't know, basically we build a Formula style race car each and every year. Basically, we design, build, test, and compete with it. The Society of Automotive Engineers basically releases a rule set each and every year, and we're required to follow that for our car. But they're basically the parent organization of all the cars here in the United States. Zips Racing started here in 1989. We were basically combustion from 1989 all the way until 2024. And then in 2014, we had a sister team start that was Zips Racing Electric, and we were basically building 2 cars a year all the way up until 2024. Since then, we've merged. For those that don't know, we built 2 cars so far under the merger, and this is our second. So we've merged both electric teams, and we're just here now with our second car. With all that stuff out of the way, we have one unified Zips Racing now, Zips Racing team now, we're 50 students deep this year. We've grown just a little bit, had a big freshman class, but basically you can see that we have gotten just over 50% of the team to be freshmen, which is awesome. We had a really good recruiting season, but that's something that we're really happy about. Obviously, we're mostly mechanical engineers, but we're also electrical, aerospace. We're also home to any major that is passionate about what we do. Basically, the only other thing I want to mention is that we compete in 2 other competitions here in the United States. That's here in Michigan, and then New Hampshire. We also go to Europe, but that doesn't happen every year, just due to the fact that it's expensive. We've still been the only team here in the United States to go 8 times in the last 15 years, so we're really, really proud of that. Unfortunately, those were all as a combustion team, but we're currently building the team back up to go this time as an electric team. Like I said, we are primarily mechanical engineers, but we're hoping to get back to Europe in 2028 timeframe. So yeah, with all that stuff out of the way, I will get into ZR26. So, like I said, its name is Layla. Rough car specs, it's 108 inches long, 55 inches wide, 45 inches tall. It barely fit in the elevator, but we did get it up here, so we are happy about that. Otherwise, you probably would have had to wait significantly more time for us to get up here. And you feel we're on time. The car is 426 pounds, has a 2.9 second 0 to 60 acceleration time, and has a top speed of 76 miles per hour. We cut over 133 pounds out of the car from last year compared to this year. I've never seen something like that before, so we're really, really excited about that. Our team goals really revolved around basically better efficiency for the car, lower weight, increasing knowledge transfer and doing well in design, and then getting a bunch of test time prior to competition. I'll elaborate more on kind of how we've done that this year once I explain each system, but for now that's kind of the overview. In terms of powertrain, we do have hub motors. So basically what those are is they're motors that go into each of the wheels, and that allows for all-wheel drive. You can control the torque going to each motor, and it generally increases handling characteristics and gets more power into the ground. So far we've driven 65 miles on the car, including our time in New Hampshire and also the testing that we've done before that. That's the most that we've had leading up to this, leading up to a competition in probably the last 7 years. So we're really, really excited about that part. We're currently getting ready for Michigan. I'll kind of break down now into each system of the car. So the way we're split up is vehicle dynamics, energetics, manufacturing, and administrative. Most of the car's design comes here in vehicle dynamics, here in energetics, and then here in a couple systems in manufacturing. I'm going to go into each of them and just kind of give a very glossy overview of what ZR26 is currently running. So I'll first start with VD. We'll go into the aerodynamics because it's alphabetical order. Basically, we had a new front wing and rear wing design this year. Completely revamped the main plane, which is the main element that the air is hitting, and that happened to both the front wing and the rear wing. The side arrow was an iteration of what we ran last year, but is still much improved. And basically, you can see that at 50 miles an hour, we produce 220 pounds of downforce with 98 pounds of drag. You can see CL and CD, or coefficient of lift, coefficient of drag up there, but that's just a very rough overview of our aero package. We also have active DRS, which basically means that when the driver opens or presses their foot on the throttle, the wings will actually open, allowing for more airflow, so you have reduced drag. And then obviously when you let off the throttle, the wings will close. And that allows for just more drag, which will help you brake. Now going into brakes. So this year, we didn't really change too much. Brakes, generally, as long as they help the car stop, we don't really want to change that part of it. So we don't really change things too much year to year on brakes. But we did do one thing very importantly, and that is changing the rotor material from cast iron to 4140 steel. That was to help us basically lighten the load of the outboard assembly for brakes, because weight reduction was a huge goal this year. So basically reducing that as much as possible. We switched to steel. The reason we can do that, if you are familiar with materials at all, was basically steel is lighter, obviously, and then we also have braking regen. So when the driver lets off the gas, basically the motors will actually work to help brake as well. So you don't just have mechanical braking that is functioning on the car. So basically we don't have as much force going into those calipers, they aren't heating up as much, and the rotors don't get as warm. Other than that, I'll now go into controls. That is basically a system that's focused on torque vectoring. That's just a fancy word for controlling the torque that goes into each motor. And that's generally a function of both the steering angle, so which way the steering angle is oriented, and then also what the wheel speed is. We have a first iteration model that you can see on the left-hand side, or on my left-hand side. And then you can see an example output that we've generated from testing. That generally just will tell the car for a given steering angle input and a given wheel speed, basically what a certain parameter is. But that is controls. That's our first time doing this system. The lead in charge of that has worked really, really hard, despite us having a little bit of issues with getting data this year. So shout out to her. But the next one is drivetrain. We ran single stage gearboxes last year in order to reduce rolling resistance. We switched to dual stage this year. That also allowed for a smaller packaging, which also helped to reduce weight. We cut out over 5 pounds per corner, so I think that came out to like 24 pounds total because it was a little bit over 5. So that was just 20 pounds in the gearboxes alone, which we're really, really excited about. You can see a few pictures over there, but the module or the actual drive ratio is 14:1. You'll see there's some clear caps on the wheels as well. We've been able to seal zero weight oil, which essentially means that we can seal oil that is the viscosity of water. So we're really, really happy about that because last year we had a couple issues with sealing. We ended up having to pack them with grease, which is about as fun as it sounds. Other than that, certainly last but not least, we have suspension steering. We did switch from a push rod last year to now just a direct mount suspension system. Again, that was in kind of the same vein of being able to reduce weight all over the car. You do get higher forces going straight into your damper arm, but if it's designed right, it'll obviously work. This is the first time that we've ever tried this, but it eliminates the bell crank, if you're familiar with cars, and that generally is great for saving weight. On the top right-hand side of the screen, you can see a straight column steering system as well. We exploded too many bearings last year when we were driving, so in order to lower the steering forces, or at least the out-of-plane ones, going into the actual rack, which is the bottom parallel piece that's at the bottom of the steering. Basically, we wanted to reduce the load going into that. So we switched to a straight column steering system and a direct mount suspension system. Now I'll get into energetics, which is basically the electrical side of the car and software. Our car is capable of producing 107 horsepower. As I mentioned, that is sometimes more than like some small sedan cars, but in terms of power to weight ratio, that's kind of the one thing that we beat a lot of vehicles that are out on the road today on. But just general architecture, you can see the high voltage battery is in the bottom, that big box. That basically produces a constant current, and that gets sent to the inverters, which then change it into alternating current to send to the motors. But that's just general architecture for those that are unfamiliar with electrical vehicles. I'll now get into the high voltage battery. That is also called the accumulator, but it's basically 5 segments, 588 volts, and has a 6.65 kilowatt hour rating on it. You can see a few pictures there, but we basically call the individual packs, segments, and those hold over 500 different cells. They're small cylindrical cells that generally allowed for better packaging this year and allowed us to cut over 40 pounds out of the battery, which is obviously pretty amazing for a car like this. For my electrical engineers, that is a 140 series 3 parallel configuration. And then on the circuit board side, I won't touch on it too much, but we do have a custom battery management system. Not a lot of teams are able to do that, but we reduced the board size on that by over 65%. And you can see that, not on this screen, but it's a very dense circuit board, and our energetics lead did not have a fun time designing it. On the low voltage side, we have a custom dashboard assembly. As you can see, we typically have run an off-the-shelf option from Motec, if anyone's ever heard of that, except it's very expensive. We're talking like $3,000, and our energetics lead and our software lead actually built this for $300. So the fact that we've been able to actually cut that cost has been very, very helpful, especially for me. But basically, other than that, there's also a picture of the dashboard circuit board right there. And then I'll talk about cooling as well. So we have 2 loops on the cooling system this year, one for the motors and then one for the inverters. What you can see on the screen here, at least on the right side, are some cooling simulations that we've run. And then you can also see for the inverter cooling part of the system, little module blocks that generally just help with manufacturing. We had some very complex manufacturing processes to make our plate last year, and we really wanted to avoid that. And then a motor jacket, which basically wraps around the motor to cool it sufficiently, is also shown. Lastly, I will talk about chassis. So for those that don't know, we run a composite chassis. So what that basically means is we have layers of carbon followed by an aluminum structure that we call honeycomb, and then another 5 layers of carbon. That's all sandwiched together to make the actual body that you can see. And then we also insert like other components such as a roll hoop, the crush impact zone on the front, and a few others. But basically, all we did this year was change the hard points, which is where things get mounted to on the car. We switched a lot of them out from aluminum to just switching to phenolic because we kind of overkilled it a little bit last year. So we did that and actually cut 7 pounds from the chassis as well. All these weight savings have helped to cut the weight of the car, which has really helped performance-wise. So that's my brief overview. At this point, I know I've probably exceeded 15 minutes, so I've lost the bet, but I think I'm okay with that. Basically, this is just a glimpse of ZR26. Here in a second, we'll actually get the cover off, show you. But I do want to talk about our most recent competition that we just came back from 3 weeks ago. We went to Formula Hybrid Plus Electric, which is the first competition of the year. It is in New Hampshire, at New Hampshire Motor Speedway, which is in Loudon, but that's about 10.5 hours away. So it is sufficiently smaller competition because it is so far away on the East Coast, but they have 21 teams out there. Like I said, mostly from the East Coast, so it is smaller, but it does provide a lot different challenges, I would say, compared to Michigan. With Michigan, that one has over 100 teams, and so you're kind of competing against the very best. With New Hampshire, that may not be true, but the location, the endurance is also sufficiently challenging. It's 2 times longer than what it is at Michigan. We're going from 22 kilometers to 44 kilometers. And then you also have just the fact that obviously we're going so far away. This may not seem like a big deal, like I said, but we did compete there 3 weeks ago. They basically have 5 events. You have design, product management as your static events, and then as your dynamic events, you have acceleration, you have autocross, and then you have endurance. I'm extremely pleased to announce that for pretty much the first time in team history, we were able to podium on every single event at that competition. That's also the first time that we've done that, period. Placing first in design, that's the first time we've ever done that, which is amazing. Third in product management, second in acceleration, first in autocross, and third in endurance. These results all accumulated to a second place finish at competition. That's the best that we've done since going to Hungary in 2019. So this is a very huge accomplishment for the team, and we're really, really proud of that. I really can't put into words how impressive that's been for our growth this year. Just being able to get up to a competition that early has been huge. That's the earliest competition that we've made it out to in probably like I said, the last 7 years. To be completely honest, the team has struggled at least a little bit since COVID. 2020 car was kind of built in the midst of that, and then ended up being a 2-year build. The 2022 car also ended up being a 2-year build, and it did compete in Europe. That's when we went to Austria, Germany, and Hungary. I think I've talked endlessly about that trip. But needless to say, basically in the last 7 years, we have, I guess, struggled to produce a 1-year build car that has succeeded at the same level that this one has. So it's been extremely, extremely exciting to be able to get to this point. Basically, we just haven't been able to get into that upper echelon team status, and I really think this year we finally will. These results that we've had in New Hampshire have been very confirming of that, and so right now we're just going to get ready to stomp the teams of Michigan. I mean that as a friendly gesture. But yeah, this team has proven that they are very different, and I think you'll see that once I kind of talk a little bit more about them. So I guess now I'll kind of get into the lead intro. So I'll kind of show, I'm supposed to show a video here, but for some reason it's not loading today. So we will skip that part. Going back to our team structure, like I said, we're split up into the following systems. Basically, we have system leads who oversee each of these subsystems in each of their respective categories. They are responsible for, like I said, overseeing the design, the manufacturing, and then actually assembly of each of those things. So I want to just kind of highlight each of them because they worked extremely, extremely hard. And it's taken a lot of sleepless nights, time away from friends and family, and just pretty much the utmost sacrifice. Not a lot of people see how much goes into a car like this, but if you have a son or daughter or a friend or a family member who is a lead on this team, you kind of see how much work does go into this. I'm very, very proud of these individuals, and I have a lot of respect for them because it's taken a lot of me nagging them and arguments and all of it, but we're here now, and all that you really, really learn a lot about another person, and that's been really, really great this year. So for leads, as I mentioned, they'll each come up one by one, give a short introduction, and we'll go from there. So first up, I want to start off with Ben Hawk. He's our vehicle dynamics lead this year, so he's the system lead that I was talking about, but he's overseeing all the aerodynamics, brakes. It's been a huge help with pretty much the technical side of the car in terms of, here, bottom of the stage. Yeah. Next up is Jacob Shanahan. He's our aerodynamics lead. So he oversaw the entire design of the front wing, the side arrow, and the rear wing that you'll see. He's worked really hard, basically run over hundreds of simulations at this point to optimize the arrow. So we're really, really happy with that. Sam Brownlee is our brakes lead. He stepped in August. He's a second year student and oversaw all the design of the brakes and manufacturing of the brakes. Abby's our controls lead. She's the one we talked about, who has basically been kind of overseeing a first year system. We've had a lot of growing pains trying to figure out the right role for that. She's been extremely helpful this year with finding that out. Jack Kelly's our drivetrain lead. He designed the gearboxes, the dual stage gearboxes that I mentioned on ZR26. Andre is our suspension lead. He also helped with the steering system and helped in the design of the direct mount suspension. Ethan's our energetic system lead. He managed both high voltage and low voltage and oversaw the construction on the car. Next up is Cole Barak. Don't know if I should say his last name because he doesn't like when I do that. He's our software and low voltage lead. Dylan Matthews is our high voltage mechatronics lead. Mechatronics is basically just a fancy way of saying that he built the battery, so he did all the mechanical integration, while Ethan did all the circuit boards, all the wiring, that kind of a thing. Matt Blankenship is our low voltage mechatronics lead. So similarly to Dylan, he was responsible for the mechanical integration of everything low voltage on the car, including wiring harness, and then a lot of the enclosures that are in the back of the car. Next up is Logan Brugman. He's our cooling lead this year, and he's obviously responsible for making sure nothing overheats in the car. Grant Abraham is our manufacturing lead. He's overseen pretty much the entire manufacturing phase, going from the chassis to the aero package, and he's been a huge help with making sure that all of that is gotten on the car. Anthony Marine Petrie is our chassis lead, so he oversaw obviously the main body of the car and actual physical construction of the chassis. Nick Kasich is our machining lead. He machined all the physical components that go on the car. He started really early this year. We got a lot of stuff done on time. It's part of the reason that we have a car this early. Josh Stifler is our chassis composites lead. He stepped in February to help out, which has been awesome. We unfortunately had a member who went on co-op, so that role was unfilled until February, and he was very, very helpful with stepping in to help out there. Kyle Lowry could not join us today. He's actually starting his job in North Carolina, but he's our aero composites lead, so he actually manufactured all the aero that Jacob designed. Last but not least, we have Reese Scott. She's our marketing lead, so she's been a huge help to me with actually getting things handled on the administrative side of the team. But yeah, that's kind of everyone. I basically just kind of want to highlight each of the people standing in front of me. Not even just the ones that are standing, but the ones that are sitting. They've shown so much tenacity, work ethic, and just an obsession with our mission that I've never seen on a team before. It's been really just an honor and a pleasure to guide each of them to this point. The fact that I've had the privilege to be captain this year has been really amazing, and I just have no doubt that each and every person standing in front of me is going to make the team better, not just this year, but in future years for ZR27 and beyond. This team has grown significantly in the past year. The fact that we went from 2-year builds to 1-year build and placed this successfully at New Hampshire was very, very confirming that something's changed. And so I'm confident that we've kind of turned a new leaf in a way to where now we're going to take it to anyone that wants it. And we're really happy about that for Michigan. Can I just please have a round of applause for the Yeah, everyone up here has had to manage classes. Everyone sitting down here has had to manage classes and also build this race car. And that's been kind of crazy, whether it's co-op as well. It is like probably average 80 hours a week just trying to make this thing happen. But I also wanted to thank everyone that was here, any supporters of the team, parents, friends, family, Akron faculty, sponsors. Without your support, we literally wouldn't be here. So thank you for helping to support our lifestyle, because I know it's probably a hard one to support sometimes, especially when you see how crazy it can get. But with all that being said, I'd like to finally unveil the car. Let me preface this, I guess, by just kind of going over the first that we've had this year. So just to make sure I get this right, this is the first time in 7 years that we've garnered a lot of testing time on the car. We've driven 65 miles thus far, and we seek to just keep that going until Michigan. This is the largest weight reduction that we've had year to year in team history. This is the first time we've ever had a first place finish in design. This is the best time. This is the best finish we've had at Formula Electric plus hybrid team history, finishing second overall. And this is also the fastest car we've ever had. There's a lot more that I can focus on, but the thing we have left to do this season is go to FSA Michigan in June. I have no doubt the team will be able to achieve amazing things there, and I'm really, really excited for that. Leads, I'd like seniors to be on the left side with the car, please, and then the other leads who are non-seniors just step to the right, and then we will unveil the car. We'll have everyone come around real quick. So, without further ado, this is ZR26. We're really, really proud of this achievement. It didn't come without sacrifice and commitment, but this is our chance to finally celebrate it with all of you. So with that being said, I'll stop talking. Sorry I went over 15 minutes, but that concludes the presentation part of this. We'll switch into just an open house style thing, so please find your loved ones. There's food over here. Sponsored by El Patron, which is a local Mexican restaurant here in Akron. And yeah, thank you everyone, and happy to celebrate with you.